I'm Logan Crawford, and right now on GBN, we're exploring a fantastic book, a book you won't want to miss. It is called Science About How Tornadoes and Vortexes Form and How They're Causing Planes to Crash. It is written by professional engineer Ronald B. Hardwig, and in the book, he delivers a bold, technical, and deeply researched exploration into the intersection of extreme weather and aviation safety. Drawing from a career spanning highway design, bridge maintenance, and sophisticated government and educational systems, the author uses his analytical expertise to uncover hidden mechanisms behind tornado development, jet stream behavior, and possible aircraft vulnerability. This gripping investigation challenges long-held assumptions and invites readers to rethink what they know or what they think they know about the skies above us. We're delighted to have this very talented author join us here today. We thank the team at Atticus Publishing for helping us put him on TV today, and we ask viewers like you to support authors like him by subscribing to our channel and by purchasing his amazing and powerful book. The links are below this interview. Ron, thank you so much for joining me here today.
Thank you.
Such a pleasure to have you on the show. What first led you to investigate the relationship between vortex formation, jet streams, and aviation failures?
Well, I first got interested in, first of all, I live in Southern Illinois, and I have a great grandfather that was killed in what's called the Tri-State Tornado. That's a tornado that started in Missouri, went all the way across Illinois and Indiana. It was on the ground for over 3 hours.
Wow.
And it killed almost 700 people in that time. I found out that my great grandfather was killed in that on March the 18th, 1925, on his 64th birthday.
Wow.
I happened to have gone to college down in Carbondale, Illinois, at Southern Illinois University, and I was living. I had relatives that still lived in Murfreesboro, and I lived there for a couple of years. While I was there and had worked there a little later, I got a newspaper article about the Tri-State Tornado in Murfreesboro. And that got me to thinking about tornadoes. The more I looked at it, and I read something about in National Geographic, how they thought tornadoes formed, it didn't make sense to me as an engineer and scientist, because you have what you call Newton's laws of motion. Object is still will stay still, and object in motion will stay at motion. And the third one, the most important, for every action, there's an equal and opposite reaction. For over 100 years, meteorologists have looked for the equal and opposite reaction to the air going up in the tornado, but they had never found it. That told me that if they didn't find anything in 100 years, there must be something else. And if you look at Newton's, the third law of motion, for every action, there's an equal and opposite reaction. You never see the equal and opposite reaction to the air going up in the tornado. That told me there had to be an outside source. And to me, the only outside source available was a high velocity jet stream over about 34,000 feet. And it ends up, that's what it was.
Amazing, amazing. And you're actually able to predict tornadoes using your methodology, right?
That is correct. I can even predict what the EF rating will be. What I come to find out is that the high velocity jet stream is the responsible for tornado genesis. In fact, during my research, I looked up 50 tornadoes, 10 EF1, 10 EF2, 3, 4s, and 5s, and I plotted what I called my tornado genesis plot. This was, and I looked at that, and it is in my book. And what you see, no tornadoes start anywhere if the jet stream is below about 58 knots. And the higher the velocity of the jet stream and the higher the height of the jet stream means a stronger tornado. By knowing what the jet stream is overhead, where there is a front and thunderstorms forming, if that's over 58, that's the only way you'll ever have a tornado, because the high velocity overhead jet stream is creating the tornado, and it's acting just like what we call an atomizer. I don't know if anybody's ever remembered their mother or grandmother having a little perfume atomizer where you squeeze the bulb. Yep. Well, the high velocity jet stream is the bulb. The actual tube down in the vial is the tornado itself. And the high velocity jet stream hitting that, well, it starts out, as we know, the mesocyclone. And a mesocyclone starts horizontally, and then it's through warm air, it's been up vertically. Now you have the option of two tornadoes. One would be cyclonic and the other cyclonic. And we know in the northern hemisphere, we have about 3% that are anticyclonic. But as those vortexes form, small vortexes due to the mesocyclone, when the jet stream hits one of those in the upper atmosphere, there's enough centrifugal force in the vortex that it offsets the downward pressure from the atmosphere up above, and that offsets where it hits the leading edge, and it pulls out the air from the center of the vortex. And like I say, we will see some that are cyclonic and some cyclonic. Yeah. And that is due to their rotation. Now in the northern hemisphere, everything, if it's a natural vortex caused by a landspout or water, like a landspout or water spout, they always spin cyclonically. But you only have cyclonic due to the fact you got two ends when it's been up. So one of those ends would be turning anticyclonic, and you will have those.
Amazing. The ability to predict tornadoes is a game changer when it comes to emergency preparations and weather forecasting, don't you think?
Oh, definitely. I can see where we can predict it, and I have predict tornadoes ahead of time by days or at least hours. As the front would be coming through, if we know, and this is the way I plot it to predict them, if we know where there's a high velocity jet stream, and you have to take into account the vector direction that the tornado would be moving with the front compared to the jet stream direction, but if they're in a crossing pattern, 100% of the jet stream will make the tornado. Now, if it's moving in the same direction, if it's moving at 58 knots, the jet stream would have to be twice 58 to even create a tornado on the ground. So, but knowing where the jet stream is, and they even plot this, knowing where that is and knowing where the fronts are, that the warm air and cold air front, and with the temperature, you can predict what the tornado will be, even the EF rating will be.
Yeah. In your book, you explore how vortex activity may contribute to aircraft incidents. Talk to us about the evidence you found, the patterns that you found that you find most compelling.
Well, what I've searched, in fact, in my book, I think I covered a little over 200 tornado or vortex related airplane crashes. But by now, I've actually got over 500 airplane crashes. When I first found out about tornadoes, I got to thinking, well, we know that they say that an airplane can crash due to downdrafts. Well, we have many more tornadoes, vortexes than we do downdrafts. So that got me thinking. And I looked at the first one I looked at was Air France 447 that crashed on June the 9th, 2001, I believe it was, or 09. And what I found, it's in my book, I found two vortexes. These can be seen on satellite video. You can actually see the vortex. And I found that there was a high velocity jet stream that could create that. Now, this was out over the Atlantic Ocean, but I found many of those. Even the one that with here back in January where the helicopter and the plane hit, I found that helicopter flew into a vortex, and he made the first correction. And actually, the second he flew in it one time, and he was in the center of it. Then when he flew out, that caused him to raise up and turn and raise up into 300 feet. So that's why it crashed. But I found many of them. Plus, what I'm finding is I'll go back to the Lion Air crash. That plane crashed because there was a power plant on the northwest end of Jakarta. It's a great big power plant. And well, I found that to begin with, I think if we can remember, there was another crash there on January the 9th, 2021.
Mm-hmm.
And I even have in my book, you can look at, I caught that jet stream in its action, and you can actually see the Vortexes form. What I found is we have, I'll call them tornado or tornadic vortexes, but we also have land spouts, which are water spouts and land spouts. What I ultimately found is how they form too. They form in a different way. Everything to make a tornado or a vortex, you have to have something to start it. We talked about the mesocyclone starting it if it's a tornado. But if you have a hot air plant or a power plant emitting a lot of hot air, or a volcano. In fact, they've always said volcanoes can cause tornadoes. Well, they don't cause tornadoes, but they do cause vortexes.
Yeah.
The difference between a tornado and a vortex, a tornado can be either cyclonic or anticyclonic. Like I said, since it's two ends to it, you have one that returning cyclonically and the other anticyclonic once they get up in the air. But a hot air vortex is always going to turn cyclonically, which is anticyclonic in the northern hemisphere. And what it is, those warm air vortexes, if they reach a high velocity jet stream of over 58 knots, you have a land spout or a water spout, what we call a land spout and water spout.
Yeah.
And that's what happened to Lion Air. And then, of course, wasn't a half a year later, Ethiopian flight ET-302 crashed. Well, what I found, they blame it on the aircraft industry because the plane was designed wrong. It wasn't designed wrong. They didn't know that you could have a vortex. The Ethiopian flight actually flew into a vortex that was created by the eruption of two volcanoes in the Democratic Republic of the Congo earlier that morning. I have those, and I have pictures of that in my book, a video of that. I do a lot of research using Zoom Earth satellite, because in that I can see where the jet streams and everything are, and the what are the thunderstorms I can see. Plus, I can go on the weather prediction center and see where the fronts are coming through, because they know where those are. Well, if we know where those are, all you got to do is look at where the jet stream is, and you'll know where there's going to be problem areas. And that's how I do my prediction, by knowing what the high velocity jet stream is and the direction it's going compared to the direction the front's moving, which would be the direction the tornado's moving. You do have to do the vector direction between the two.
Yeah. Very, very fascinating indeed. Let me ask you this. Why do you believe tornado and vortex research has been underestimated in discussions about aviation safety?
A good point, but let me start back a little bit further. Since for over 100 years, we've had people write new research on tornadoes. But like I said, the first thing is they forgot about the fact that a tornado can't be a function of the thunderstorm, because if it was, you had to see an equal and opposite reaction to the air going up in the tornado. We see the air going up, but we don't see what the opposite reaction is. They didn't see it. Well, one of the problems it exacerbated, I'll say this problem, was in 1973, in May of 1973, the weather system found what they call the tornado vortex signature. Now, that's what they always refer to as the hook echo. Now, the hook echo, of course, but that's after the tornado had started. But they found this hook echo by using Doppler radar. But since that time, they have tried to develop better and better Doppler radar. But there's a problem. The high velocity, well, Doppler radar works because air is invisible, so it sees stuff in the air. What it's seeing when it says it sees the hook echo, it's seeing the moisture pulled up into the atmosphere. That's what they're seeing as a hook echo. But the problem is the high velocity airstream, which is causing tornadoes, is just air. It's never seen. So for over 50 years, they've been trying to develop better and better Doppler radar, but that won't tell them where the tornado is. Like I say, if you go back to pure logic and physics, Newton, third law of motion, for every action, you have an equal opposite reaction. For 100 years, they never found anything on the ground. Well, it's time to look somewhere else. In fact, I was flying back from California one year, which helped me clue me into this. And I was flying back from California to St. Louis. They said we'd be arriving in St. Louis 35 to 45 minutes earlier because we've been flying in the jet stream at 32,000 feet. Well, that clued a couple things in my mind. I remembered that cumulus clouds that form tornadoes really go up to about 32,000 feet. And I also remembered one thing in my physics class about entrainment, and that talks about air being entrained. And that's actually what happens when we speak of an atomizer. That is entrainment. That's the way it works. So when I got back, I started even thinking about it even more. And then, of all things, as an engineer, I bought an antique steam car, a 1922 antique Stanley steam car. Actually runs on steam, just like a steam locomotive. Now, one of the things they have in that steam car is what's called a Venturi tube. Well, that's just like the Bernoulli principle, in that it's entrainment, and it uses the pressure of steam going in a tube. And if I have a hose coming down where the air is going out, I can suck water into my tank faster than you could with a garden hose. It does it by Venturi action. And that's what's happened. That's really how a tornado works. So that helped me along the way.
Yeah. Your book touches on MH370. What aspects of that disappearance align with the atmospheric mechanisms that you talk about?
Well, actually, let's talk about two different things. I thought that plane had made the deviation in the South China Sea when I first heard that. But I started looking during my business or occupation as an engineer. I've done a lot of drawing and drafting. So I tried to draft it up on a flat piece of paper, but you can't do that. But what I did do, of course, we know from the burst frequency different signals, we know the distance at about 5 or 6 points. It was from the satellite at 64.5 on the east on the equator. But we also, something else people have overlooked. We know the time it was at that point, the 1, 2, 3, all those points, which gives us another dimension. We know the time it flew from that point to that point, then the next second to third, fourth to fifth. That gives us a dimension. Now, figuring out what speed the plane would fly, there's only one place that plane could have flown, and all those line up, and that's what I found. First of all, I looked at the natural, common, normal speed of the plane, and I found that to be wrong. But it didn't take me long. I used the fastest speed the plane could have been flying, and that checked all right. Every distance from the satellite and to the plane at each point checks out exactly. That's why I can tell them where the thing crashed. Now we have to I used at first the bearing from the hydrograph from the southwest Australia, but I think it would be better to use the time, because I think the hydrograph will be off by a few degrees, but by time we can actually figure it out. I did this because, like I said, I've done a lot of drafting. While doing all my plane research, I could plot. I would find out where maybe a power plant, a lot of nuclear power plants, and that's how I first found out this. There was I had an accident in Moscow, and I got to wondering, there was no bad weather around, but I was wondering if the hot air from a nuclear power plant could cause cause a vortex. And yes, it did. And I found that's how that plane crashed. And they mentioned another plane that had crashed 2 years before down in Roscoe-on-the-Don airport in southern Russia. That, of all things, that vortex was formed by the power plant in Ukraine, the one that they're arguing over right now and closing. That the power plant had created that vortex. I might be meandering on a little bit.
No. It's fascinating stuff, all of it, no doubt. Talk to us a little bit about how jet streams and high velocity wind corridors interact with aircraft during flight and why these interactions can become dangerous.
Well, we talked about the fact, one, it's not dangerous if they're flying with it. But if they're going to be flying, what needs to be done? And I even talked to David Dempsey at San Francisco State University years ago about doing this, but I financially can't do it. We make up maps right now of where when I first looked it up, in fact, excuse me a minute, where the 300 millibar jet stream was. But we can make up a jet stream map of anywhere it's over 58 knots. That's what needs to be done. That, and take the direction it's moving, and if it's over 58 knots, overlay that with where any planes would be flying or any fronts would be passing through. Then we will know where to predict where planes might have trouble. We also need to make a second map of that jet stream, or use that same jet stream, noting where they need to find out what power plants. I got a number of them.
How do you feel your findings might influence future aircraft design or even safety protocols?
Well, design definitely. Looking back at the 737 MAX 8, where it had the trouble Lion Air and Ethiopian flight, I had my research out before that, if they had known. The problem is they have what they call the AOA sensors. This is angle of attack. And they talk about the CMS system, maneuvering system. The thing is, you have to have an AO system on each side independent. Because if you get a plane flying into a vortex head on, the AOA sensor on one side is going to sense one thing, the AOA sensor on the other side, because one side is going to be streamlined flow, so it's going to be straight. But if the one on the side, the vortex is coming, it's going to make it change up or down. That's what happened to both planes. I know that's what happened to both planes. Now, I don't know the other planes, if they're designed it the other way or not, but I know the Boeing 737 MAX 8 was not at that time. So they got to take in both things. If they both read the same thing, the plane's just going up or down. But if one of them comes up and goes down, you're in a vortex on one side. The other side, where the air, by the time it goes around the nose of the plane and gets to the AOA sensor, it's streamlined flow. So it's going to be straight with whatever place the plane's going to fly. That's the difference. That's where they messed up, and they didn't pick that up.
Yeah. What do you hope aviation professionals, scientists, and readers, everyday readers, ultimately take away from your book?
Well, the bottom line is, we've tried for 100 years to predict tornadoes. I can tell them. I've told them I have predicted tornadoes. When about 10 years ago, and 2013, I went to my local weather station down in Lincoln, Illinois. And I talked to them for about a year trying to get in. They didn't want to talk to me. I'm a nobody, of course. And after they said they'd allow me to talk to about 5 or 10 minutes. I talked for an hour and a half, and they agreed that I was onto something. This was just the tornado research. They said, well, you need to either write a research paper or talk to the storm prediction down in Norman, Oklahoma. Well, I'd never written a research paper, and I'm not affiliated with the university, so I wouldn't be up on that. So I thought I'd talk to the one down in Norman, Oklahoma. I
Mhm.
called him. This was in October. On December the 31st, the same year, right before in the afternoon, I got an email back that they knew everything about the high velocity overhead jet stream and not to bother them anymore. I told them that it was related to the high velocity, so they knew to say that. Well, the guy, like I said, don't ever call us again. I'm glad you asked me this question, in fact. About a year later, through another friend who antique car, since I have the Stanley, he said, I have a relative that flies in the planes that fly through hurricanes. And he said, I'll give you his name and let you have you give me a contact. Well, he gave me a contact, and lo and behold, that contact I contacted in Norman, Oklahoma, got me back to the first guy.
Wow.
And the first guy said, I told you to never call me again. I said, I know, but this guy gave me your name. He said, well, I'll tell you what. You predict a tornado, then I'd believe it. Well, it was December of 2014. So I didn't expect too much. However, it was either I think it was December the 21st. I'd been looking, and that morning I said, we're going to have tornadoes in the lower portions of Louisiana, Mississippi, and Alabama today. There will be some, and the highest one will have an EF rating of 14. Not EF 14, EF 3. Reason I say 14, there was 14 tornadoes, and the highest rated one was an EF 3, just like I predicted. He said this had to be a fluke and refused to talk to me again. Yeah, I've written reports. Like I said, I wasn't affiliated with the school, so to write a research paper would be entirely new to me. But I tried 5 times. The first time, they said, well, we're just not interested. The next 2 times, it was reviewed by meteorologists. They say it doesn't agree with anything we've had research. The thing is, they've had 900 research papers accepted, but not one of them ever came to a conclusion that mine's wrong. So I wrote the 6th one, and it went again. I didn't know it, but National Weather System, something like that, reviewed. Happened to be viewed by a gentleman at the Storm Prediction Center of NOAA. Well, he wrote me back within about 3 days. He said, well, I found a tornado where there was no high velocity jet stream. Well, what it was, the tornado was in far northeast Kentucky. And he was looking at the jet stream at Nashville, Tennessee, 275 miles away. Well, I look at ones in Ohio and Virginia. There's a jet stream. I found it, but nothing would do him. That you can't be right. You can't be right. Well, at the same time, I struck up a conversation and another fella in the Storm Prediction Center, and I'd sent him predictions I made in January of 2017, and I'd made predictions for 5 days. I put where there would be tornadoes, and I put down what the highest EF rating would be. Everyone was correct. Nobody, but they wouldn't do anything. The one guy wouldn't let my research paper be reviewed. So I wrote to the Office of Inspector General about the waste of tornado research funds. When they were interviewed, they lied, saying my research wrong, bad results or false warnings. Well, I'd already given them the warning that it was correct, but they still lied about it. I complained. That went nowhere. I complained to my 2 senators. That went nowhere. But what I think it did, it messed me up with the National Transportation Safety Board, because they refused then to look at any of my research. I predicted, or I found a tornado that caused a plane crash, MU-2B, in May of 2017, and I wrote them about that. I tried for 6 days or 6 weeks to get somebody to talk to. They never would return the call. Finally, he said, just send in eyewitness reports. Well, I did that, which would have included the time of Ethiopian flight and Lion Air flight, but they never got back to me. But then I think it was the one on 2001, January the 9th, there was a Sarajevo plane that took off from Jakarta and crashed, killed 62 more people. That's the one. I actually have video satellite of the Vortexes forming. Now, what happens when you have vortexes forming from a hot air source? You'll have one after the other. As it goes up, the jet stream hits it, it pulls it apart. But that hot air source is still there. So the hot air source will come, it'll make another one. That's even covered in my book. There was a plane that had to land in Hawaii that had flown into one of those. And I show about 7 of them in satellite views. You can see one after the other forming.
Yeah. Amazing. Amazing. Well, I think you're proving all the naysayers wrong. I think you've written a book now that really sets forth in black and white the science behind your research and the explanation for a lot of phenomenon that has been elusive to the scientific community for a long time. The name of the book we've been talking about today is called Science About How Tornadoes and Vortexes Form and How They Are Causing Planes to Crash. It is written by professional engineer Ronald B. Hardwig, and he delivers a bold, technical, and deeply researched exploration into the intersection of extreme weather and aviation safety. Ron, thank you so much for joining me here today.
Thank you very much, Mr. Crawford. I enjoyed this immensely.
I enjoyed speaking with you as well, found it so insightful. To the folks at home, I'm Logan Crawford for the Global Book Network. So long for now.